An average is one of the most widely used statistics. Average income, average height, average profit. But an average can be seriously misleading. This is why we need distributions. They give us the full picture, not just a single number. Take two professions, an accountant and a writer. Both have a similar average salary, somewhere around $80,000 a year. Look at the accountants first. Their salaries are tightly clustered around that average. Most accountants earn close to $80,000. Now look at the writers. A small number are wildly successful, earning millions from best-selling books. But the typical working author earns closer to $20,000 a year. The average describes almost no one in the writing profession. Writers and accountants have the same average salary, but completely different stories. Today we are going to see what probability looks like when it takes shape. We will cover the distributions that show up again and again in data science. The binomial distribution, the normal distribution, the Poisson distribution, and the power law. By the end of this video, you will never look at an average the same way again. Let us start with the simplest distribution, the binomial. Here is the idea. You have an event with a certain probability, and that event can repeat. Take a fair coin, 50% chance of heads. Flip it twice, or 3 times, 4 times, 5 times. Every time, the binomial distribution tells you the probability of every possible outcome. But real events are not always 50-50. Here is a concrete example. 2 football teams face each other in a penalty shootout. Team A is the stronger side. Each of their penalties has a 60% chance of going in. Team B is weaker. Their conversion rate is 40%. The question is, how many penalties should they take? Start with just 1 penalty each. Team A scores and Team B misses. Probability, 36%. Team B scores and Team A misses. 16%. Both score or both miss. That is a draw. 48%. Almost half the time, 1 penalty decides nothing. So what happens when we require 2 penalties? 3, 5. Watch the draw probability collapse. At 2 penalties, the draw falls to 34%. At 3, 27%. At 5, still 20%. At 7, 16%. And here is the other thing that happens. As the draw probability falls, Team A's true advantage starts to show. With 1 penalty, Team A wins only 36% of the time. With 7, that rises to 69%. This is what the binomial distribution quantifies. The probability of every possible outcome across any number of repeated trials. The most famous distribution in all of statistics, the normal distribution. You have seen this shape before. It shows up everywhere. Human height, blood pressure, IQ scores, measurement errors from any precise instrument. All of them follow the same bell-shaped curve. A normal distribution is fully described by just 2 numbers. The mean, which tells you where the center is. The standard deviation, which tells you how spread out the data is. A small standard deviation means everything is tightly clustered. A large standard deviation means it is spread out. Same center, different shapes. Now here is one useful trick. In a normal distribution, about 68% of the data falls within 1 standard deviation of the mean. About 95% within 2 standard deviations. And about 99.7% within 3. This rule changes how you think about numbers. Let us apply it to football. At the end of each half, the referee adds stoppage time to make up for time lost. Across Europe's top competitions, that stoppage time has historically averaged around 6 minutes per match, with a spread of about 2 minutes. So about 68% of matches have between 4 and 8 minutes added. 95% between 2 and 10. And 99.7% between 0 and 12. But here is the critical warning. Not everything is normal. Income, housing prices, view counts on social media, wealth. None of these are normal. 2 more distributions. These are the ones that break our intuition. First, the Poisson distribution. Poisson counts rare events that happen at a steady average rate. How many goals will be scored in the next Champions League match? How many emails will arrive in your inbox in the next hour? How many earthquakes will hit California this year? Each of these is a Poisson process. All you need is one number, the average rate. Champions League matches average around 3 goals per game. From that one number alone, Poisson tells you everything else. The probability of 0 goals in a match, about 5%. Of exactly 3 goals, about 22%. Of 7 or more goals, about 3%. Now the last one, the power law. Remember the accountant and the writer from the start of this video? Here is why their salaries told 2 completely different stories. Income does not follow a bell curve. It follows a power law. In a power law, almost everyone is at the bottom, and a few are extraordinarily far above. The same shape appears almost everywhere humans accumulate things. Book sales. Most books sell a few hundred copies. A few sell millions. Social media followers. Most accounts have a few dozen. A few have hundreds of millions. Wealth itself. Globally, the top 1% owns more than the bottom 50. The power law breaks everything you think you know about averages. If your data follows a power law and you treat it like a normal distribution, you will be catastrophically wrong. For distributions, here is a quick way to choose between them. Counting yes or no successes, binomial. Continuous data clustered around a mean, normal. Counting rare events in time, Poisson. Anything where a few outliers dominate everything, power law. Choosing the right one matters. Choosing the wrong one is expensive. Before you do anything with data, plot it. Look at the shape. Decide which distribution fits. Then choose your tools. In the next video, we tackle the most important theorem in all of statistics, the central limit theorem. It explains why the bell curve keeps appearing even when the data underneath is anything but normal. And it is the reason every statistical formula you will ever use actually works. Subscribe to the Plotline if you want to understand the theory behind data science. See you in the next one.